Assalamu alaikum guys. So today we are going to be doing a bit of calculation related questions and some other questions that come along with calculations for AS chemistry, all right? So it's the first year of A levels, those calculations, all right? So let's look at the first question. Combustion data can be used to calculate the empirical formula, molecular formula, and relative molecular mass of many organic compounds, all right? Define the term relative molecular mass. All right, so what is relative molecular mass? So you want to first of all explain what is molecular mass, and then you want to explain what relative is. All right, so you explain molecular mass. It is the average isotopic mass, or we can say average mass of isotopes of an element. Average mass of isotopes of an element, right, relative to, or you can even say compared to, 1/12 of the mass of carbon 12 isotope. All right, so this is the definition of um, relative molecular mass. All right, next question we have: T is an alcohol, CXHYO. A gaseous sample of T occupies a volume of 20 centimeter cube at 120 degrees Celsius and 100 kilopascals. All right, the sample was completely burned in 200 centimeter cube of oxygen, which is an excess. The final volume measured under the same conditions as the gaseous sample was 250 centimeter cube. All right. Under these conditions, all water present is vaporized. That means water over here is also a gas. Removal of water vapor from the gaseous mixture decreased the volume to 170 centimeter cube. This means that from 250 centimeter cube, once we removed all the water vapor, the volume decreased down to 170 centimeter cube. That means the volume of water over here should be 80 centimeter cube. All right, the volume of water over here should be 80 centimeter cube. All right, okay. Next, what else are they saying? Treating the remaining gaseous mixture with concentrated alkali to absorb carbon dioxide decrease the volume to 110, meaning going from 170 to 110, this is 60 centimeter cube. 170 minus 110, that is 60 centimeter cube, right? All right, so going after removing carbon dioxide, we find out that volume of carbon dioxide is 60 centimeter cube. All right, we also know that our sample occupies a volume of 20 centimeter cube. All right, so our sample is 20 centimeter cube. Okay, and of course, if after carbon dioxide is absorbed and if the volume is decreased down to 110 centimeter cube, that means out of 200 centimeter cube, how much oxygen reacted? If 110 is left, we will say 90 centimeter cube of oxygen must have reacted, and 110 centimeter cube of oxygen was the excess one. All right, once we write all this, let's look at the first question. Use the data given to calculate the value of x. We want to calculate the value of x, we want to calculate this value. All right, to calculate this value, you have to ensure that the coefficient of whatever our fuel, our alcohol is, has to be 1. Then you can calculate out x. All right, right now, from looking at these values, and here's a sneaky trick, you can use volumes as literal moles. All right, volumes can be used as moles in questions like these. That's why these questions are 1 mark each. Basically, what I mean to say from that is, if a sample of 20 centimeter cube is reacting with 60 centimeter cube of is reacting to produce 60 centimeter cube of carbon dioxide, then we can say that 20 moles of our substance produces 60 moles of carbon dioxide essentially. All right, so we want to calculate out CXHYO, all right, is to CO2, all right, 20 is to 60, all right, we want to make it 1, so how much would that be? Going from 20 to 1, that is divided by 20. So going from 60 We should also divide this by 20. 60 divided by 20, that is 3. So the value of x must be 3. All right. Why did I do it 1? Because we wanted to find out how much 1 mole of our alcohol would produce how much carbon dioxide. All right. So that is how you do the first question. Next, use the data given to calculate the value of y. So we want to calculate the value of y now. All right. Similarly, we can do the same exact thing, or we could have just done it over here. If we wanted to make it 1, we could have just divided everything by 20, right? So it would have become 1 is to 90 divided by 20 is 9 upon 2. All right. Gives us 60 divided by 20 is 3 and 80 divided by 20 is 4. All right. So Cx HYO is to ZO2 gives us X CO2 is to Y upon 2 H2. All right. H2. All right. Now we found out that X is 3. We've also found out that Y upon 2 is equals to 4 because of this equation. So we say Y upon 2 is equals to 4. Therefore, Y is equals to 4 times 2 equals to 8. So the value of Y over here should be 8. All right. On to the next question then. The composition of atoms and ions can be determined from knowledge of atomic number, nucleon number, and charge. Complete uh, complete the table. All right. So the first row, atomic number 3. What would be its nucleon number? Well, the symbol is given to us. Nucleon number is basically the atomic mass, which is 6. So we will write over here 6. All right. Number of protons is what atomic number is, meaning 3. All right. And number of neutrons are basically atomic number minus the nucleon number. So 6 minus 3 is 3. All right. Now the next down here, over here, we know number of electrons are 23, number of protons are 26, and number of neutrons are 32. They're asking the atomic number. So the atomic number is always number of protons, all right? So it should be 26. Now the next thing is that you want to tell the nucleon number. Nucleon number is basically the sum of protons and neutrons, the sum of protons and neutrons. So when you add 26 and 32, what do you get? When you add 26 and 32, let me just get a calculator 1 second. When you add 26 and 32, 20 and 30, that is 50, 56 and 2, that should be 58. All right. Let me just confirm it from my calculator now. 26 plus 32, that is 58. Yeah. So the nucleon number should be 58. So the element is the element with atomic number 26. If you don't know who atomic number 26 is, go to the periodic table and search for the guy with the atomic number of 26. We know that is our boy iron. All right. Mass can be anything. Atomic number never changes. All right. So it's Fe. All right. So it's 26 Fe. All right. So let's write its atomic symbol. It should be Fe. All right. Its mass is 58. Its atomic number is 26. And you should also observe one more thing before moving on to a next question. Whenever this question comes, you should always observe that they will give you different number of protons and neutrons. Now they've been given you 3 more protons than neutrons. Therefore, this guy should have a +3 charge. All right. So you want to write +3 over here as well. Okay, next question. Boron occurs naturally as a mixture of two stable isotopes, 10B and 11B. The relative isotopic mass and percentage abundance are shown. All right, 11B, we want to calculate its relative isotopic mass. We are given everything else. Okay, define term relative isotopic mass. So now they want to ask you what relative isotopic mass is. Basically, relative isotopic mass would have the same definition as relative atomic mass, but instead you won't say average mass of all the isotopes, you would just say mass of isotope of an element. All right, so mass of the isotope of an element of an element relative to 1/12 of mass of carbon 12 isotope full stop. All right. Next question. Calculate the relative isotopic mass of 11b. All right. So we want to calculate the relative isotopic mass of 11b, which is not given to us. So the formula to calculate the abundance or relative isotopic mass, we are only given one. In our whole syllabus, we always use this formula, right? We say that average atomic mass is equals to summation of percentage abundance multiply by isotopic mass, right? Divided by 100, right? This is the formula. Now AR, if you don't know, once again, you can just go over here and you can check the AR of boron. The AR of boron is given as 10.8. That is what we are going to take, right? So the AR of boron is 10.8 is equals to summation. We are going to make two brackets. One is for 10 boron, which is 10.0129. All right, 10.0129 multiply by 19.78 plus bracket x multiply by, because I have written x because I don't know this, a mass multiply by 80.22, 80.22 bracket close divided by 100. Now you and I both know 100 goes on the other side and it will multiply with 1080, and when it multiplies with 10.8 it should produce 1080, as I said, right? 10.8 times 100, that should be equal to 1080. Yeah, so we'll get 1080, and then this whole bracket, better this whole bracket, it can be solved and can go on the other side and be subtracted. So I'm just going to take it on the other side and subtract it from 1080. But first I'm going to find out what its value is. 10.0129 times 19.78. What would that give us? 198.055. All right, 198.055. Another reason why I'm putting it this many things, this many numbers, is because they've asked us to give you answer in 6 significant figures. So try and after decimal, try and go for 4 5 decimal places to make 6 significant figures. All right, is going to be equal to 80.22x. All right, because we've taken 100, multiplied it, we've taken this bracket and subtracted it. Right here, this is the bracket, so all that is left on this side is x multiplied by 80.22, which should give us 80.22x. Now we want to subtract 1080 from our answer. That should be 881.945. All right, so our answer is 881.945 is equals to 80.22x. Therefore, so x should be equal to 881.945 divided by 80.22. All right, so this answer must be divided by 80.22. That should give us 10.9941. All right, so the answer is 10.9941. All right, because it's actually 407, but this is a 6 significant figure, so we are going to round it off over here and we are going to make it 1. So the final answer is 10.9941. All right, this is our final answer. Okay, on to the next question then, beta. Mohr salt NH4 whole twice FeSO4 whole twice dot XH2O is hydrated form of ammonium iron 2 sulfate. X represents the number of moles of water in 1 mole of the salt. A student wanted to determine the value of X. 0.784 grams of hydrated salt was dissolved in water and this solution was acidified. Okay, all of the solution was titrated with 0.0200 mole per dm cube potassium magnate 7. 20 centimeter cube of this potassium magnate 7 solution was required for complete reaction with Fe2 plus ions. Okay, use changes in oxidation number to balance the equation for the reaction taking place. We want to balance the equation. using changes in oxidation number. For that, we have to first write the oxidation numbers. So beta, we see that MnO4 has a minus charge, meaning the overall charge is -1. Out of that, because of 4 oxides, it should be -8. So Mn should be +7. That is why there is an overall -1 charge, right? So that has been confirmed. Okay, next. So instead of writing -8, let's just write -2. We understand that -2 times 4 is -8. Okay. Next, Fe2 plus, all right, it's oxidation. H plus is oxidation. This oxidation, all the oxidation states are written. H2, we don't really need to write the oxidation state. I mean, we do know that it is H and OH, and the OH is minus and H is plus, but it's okay, because in that you already see that Mn +7 to Mn +2, this oxidation state is decreasing. This is reduction, right? And how many electrons has it gained? It has gained 5 electrons, all right? And then Fe2 plus has gone to Fe3 plus, right? This is also something we can observe, right? And this is oxidation. And how many electrons can we say it has gained or lost? Sorry, it has lost 1 electron, right? Right now it has lost 1 electron. That is why it has gone from 2 plus to 3 plus. But Mn, we say it has lost 5 electrons. Why do we say it has lost 5 electrons? Because it has gone from +7 to +2. That is a decrease in 5 oxidation numbers. So that means it should have gained 5 electrons. All right. Now, when this is said and done, what we need to do is we need to balance the amount of oxygens lost and oxygens gained. What does that mean? It means that if 5 electrons are gained, that means 5 electrons must be lost. For now, 1 electron is lost. We multiply it by 5 to make it 5 electrons lost. And how can we multiply it by 5? By putting a 5 behind Fe, right? 5 Fe2 plus, when they will become 5 Fe3 plus, so each Fe has lost 1 electron. 5 Fe2 plus have lost 5 electrons in total. All right, that is how you balance this. And now, once the number of electrons lost and gained have become equal, number of electrons lost and gained have become equal, just balance the number of atoms now. All right, like for example, MnO4 is ones, so this should be ones. All right, because O4 is 4 times, right? So this should be 4 right here, so that oxygens can become 4 times. All right, and now hydrogens to 8 hydrogens, so this must be 8 over here. All right, so this is how you balance this complete equation. Next question is, state the role of Fe plus 2 ions in this reaction. What is the use of Fe plus 2 ions? Why are we seeing Fe2 plus ions in this equation, and what role are they playing? So the answer is very simple. Just look at Fe. What do we see about Fe? Fe's oxidation state is increasing. Fe2 plus is getting oxidized to Fe3 plus. If it is getting oxidized, that is not its role. But because it is getting oxidized, that means it is the reducing agent as well, because reducing agents are the ones that are getting oxidized. So we will say it is a reducing agent, and because it is a 2-mark question, so we say it is a reducing agent as loses an electron which another species will gain and get reduced. Another species will gain and get reduced. All right, so this is the way you solve this question. All right, on to the next question. Calculate the amount in moles of magnate 7 ions that reacted. So we want to calculate the amount in moles of magnate ions that have reacted. All right, so for that we have to do one thing. Just but give me a moment. All right. So the next question they had asked is, calculate the amount in moles of magnate 7 ions that reacted. ठीक है? तो question के अंदर you were given something very important. What was that given? 0.784 grams of hydrated salt dissolved in water, and this solution was acidified. All of the solution was titrated with 0.0200 mole per decimeter cube of potassium magnate. 20 centimeter cube of this potassium magnate solution was required for complete reaction. So we know the concentration of potassium magnate solution and we know its volume. So what formula can we use? We can use the formula mole equal to concentration multiplied by volume. All right, mole is equals to concentration multiplied by volume. Next we do the value 0.02 multiply by volume is 20 centimeter cube. We divide 20 centimeter cube by 1000 because we want it in dm cube, because the concentration that was given to us, and it's always given to us in mole per dm cube. Well, when I say always, I mean for the most of the times. Okay, all right. So now we do 0.02 multiply by 20 and divided by 1000. So we get 4 into 10 to the power minus 4. All right, so 4 into 10 to the power minus 4 moles. These are the number of moles of magnate ions that reacted. Calculate the amount in moles of Fe2 plus that react. All right, just one last time. All right, so the next question, calculate the amount in moles of Fe in the sample, right? So we want to calculate the amount of Fe2 plus in the sample of salt. Okay, we know, well, we don't exactly know how much Fe2 plus the molecular mass of the whole of Fe2 plus, right? And we know how many moles of it reacted. All right, we are going to use the mole, right? And the molar ratio is going to go like this: N/4 minus is F E. The ratio is 1:5. Right? So should only been done one balanced directly. Next thing we will do is 4 into the minus 3 moles. So moles or would have been used. So how much Fe plus 2